Let's practice some parenteral dosages. Let's say the doctor orders Demerol 50 milligrams IM, and the supply is labeled Demerol 75 milligrams per milliliter. How many milliliters do we need to give? We can perform this calculation in all four methods that we've seen previously. First, let's use the rainbow method. We're going to put down what we know our relationship is between milligrams and milliliters. The supply tells us that there's 75 milligrams in each 1 milliliter. The doctor ordered 50 milligrams, and we need to calculate how many milliliters this will be. To solve for x, we need to multiply our means and our extremes. We can do this. 75 milligrams times x ml equals 1 ml times 50 milligrams. In order to isolate our x on one side of the equation, we need to divide both sides by 75 milligrams. By doing so, the 75 milligrams cancels on the left-hand side, leaving our x by itself. On the right-hand side, only the units milligram cancel, and we are left with 1 ml times 50 divided by 75. When you do this calculation on your calculator, you end up with 0.6666 repeated. Since we know we need to round to the tenths place, we only need to look at the first two numbers after the decimal point. The 6 is in the tenths place. The number next to it tells us to round up. Therefore, we need to give 0.7 milliliters to our patient. We can also use the proportion or fraction method to solve this equation. We'll first set up a fractional relationship between milligrams and milliliters, and we know from the problem that 1 milliliter is equal to 75 milligrams. We're trying to find out how many milliliters are equivalent for 50 milligrams. We then can use cross multiplication to solve for our x. We will multiply 1 milliliter times 50 milligrams and set that equal to 75 milligrams times x milliliters. Again, to get x by itself, we need to divide both sides of the equation by the 75 milligrams. By doing this, the 75 milligrams cancels out on the right-hand side, leaving us just with x mLs. On the left-hand side, only the unit milligrams cancels, and we're left with 1 times 50 divided by 75. When you do this on your calculator, you get 0.66666 repeated. Since we want to round to the tenths place, we'll look at the two numbers after the decimal. The first 6 is the tenths place. The number after it tells us to round up. Therefore, we give 0.7 milliliters. We can also use dimensional analysis for this calculation. In this case, we are going to start with our order of 50 milligrams. We then want to multiply by a fractional relationship that will cancel out milligrams and leave us with milliliters. We can tell from the supply that each milliliter has 75 milligrams in it. The milligrams cancel, and we're left with the unit milliliters. When we multiply 50 times 1 divided by 75, we end up with 0.66 repeated. The first 6 is in the tenths place, and the number after that tells us to round up. Therefore, we give 0.7 milliliters. The fourth way to perform this calculation is the formula method. In this case, we're going to take the dosage ordered, 50 milligrams, divide by what we have on hand, the 75 milligrams, and multiply by the way we're delivering it, the 1 milliliter. Again, the milligrams cancel, and we're left with 50 divided by 75 times 1 ml. We end up with 0.66 repeated. We look at the first two numbers after the decimal. We know we need to round to the tenths place. The 6 is currently in the tenths place, and the number after it tells us to round up. Therefore, we need to deliver 0.7 milliliters to this patient. Let's try another problem. This time, the doctor orders morphine sulfate grain 1/4 IM every 4 hours as needed for pain. The medication is available in morphine sulfate 15 milligrams per milliliter. How many milliliters should be administered? First, let's do this calculation using the rainbow method. As you can see, the doctor ordered grain 1/4, but the medication is available in milligrams. So our very first step is going to be to convert grain 1/4 into milligrams. We can do this because we know a relationship between grains and milligrams. We know that grain 1 is equivalent to 60 milligrams. We need to calculate how many milligrams are in grain 1/4. We can do this by multiplying our means and our extremes. Grain 1 times X milligrams equals 60 milligrams times grain 1/4. We'll divide both sides by grain 1 in order to isolate our X. And when we multiply 60 milligrams times 1/4 divided by 1, we find we need to give 15 milligrams. We then can calculate the number of milliliters we need to give in order to administer this 15 milligrams. We can see from the supply that there's 15 milligrams in each milliliter. The doctor ordered 15 milligrams, and we need to decide how many milliliters in order to give. We'll again multiply our means and our extremes. We get 15 milligrams times X ml equals 1 ml times 15 milligrams. To get X by itself, we divide both sides by 15 milligrams. And as you can see, we will deliver 1 ml. Another way to do this operation is using the fraction method or the proportion method. We again, because the doctor ordered grain 1/4 and the supply is available in milligrams, we need to convert grain 1/4 into milligrams. We can do this because we know that grain 1 is equivalent to 60 milligrams. We then can calculate that grain 1/4 and figure out the number of milligrams that that's equal to. We can do this by cross-multiplying grain 1 times X milligrams equals 60 milligrams times grain 1/4. You can divide both sides by grain 1 in order to isolate the X. And we discover that X milligrams is equal to 15. We then will create a fractional relationship for our supply of milligrams and milliliters. We know that 15 milligrams is equivalent to 1 ml. We need to give 15 milligrams, so we can ask ourselves how many mLs this is. Now you can go through the cross multiplication, or you can see that our dosage isn't changing, therefore the volume isn't going to change, and we're going to give 1 milliliter. The third way to perform this calculation is by using dimensional analysis. In this case, we'll start with the doctor's order of grain 1/4. We will then convert grains into milligrams so that the order matches the supply. We can do this by putting grains at the bottom so that grains cancel and milligrams at the top so that that's what we're left with. We know that there's 60 milligrams in 1 grain. This cancels out the unit grains. We then can multiply by our relationship between milligrams and milliliters from the supply. We'll put milligrams at the bottom so that the units cancel out. And we can see that there's 15 milligrams in each milliliter according to our supply. We now can multiply 1/4 times 60 times 1. We end up with 15. At the bottom we have 1 times 15, again 15. Simplify that and we see we need to give 1 milliliter. We can also use the formula method to do this calculation. The order is for grain 1/4 and the supply is available in 15 milligrams per ml. We need to convert grain 1/4 into milligrams. We can do this by taking our grain 1/4, dividing by grain 1, and multiplying by the 60 milligrams I know that's equal to. When we do this, we find we have 15 milligrams for our order. We then will take the order of 15 milligrams, divide by the 15 milligrams on hand, and then multiply by the quantity it's delivered in, 1 milliliter. Milligrams cancel, and if we divide 15 divided by 15 times 1, we discover we need to administer 1 milliliter. Let's try another one. This time, the physician orders 175 micrograms subcut every day for 2 weeks. We can see that the medication comes in a single-use vial labeled 480 micrograms per 1.6 mL. We want to know how many milliliters we need to administer for each dosage. We will first use the rainbow method to do this calculation. Let's set up what we know. We can tell from the supply we have 480 micrograms for every 1.6 milliliters. We know we need to give 175 micrograms, but we need to find out how many milliliters that's equivalent to. We then will multiply our means and our extremes. We have 480 micrograms times x mLs equals 1.6 milliliters times 175 micrograms. We will divide by 480 micrograms on both sides in order to isolate the x. We can see the 480 and the micrograms cancel out on the left-hand side, just leaving us with our milliliters. On the right-hand side, the unit micrograms cancels, and we're left with 1.6 mLs times 175 divided by 480, and we end up with 0.58, but we want to round to the tenths place. The 5 is in the tenths place. The 8 tells us to round up. Therefore, we will give 0.6 milliliters. We can do the same calculation using the proportion method or the fraction method. In this case, we're going to set up a fractional relationship between micrograms and milliliters. We can see from the problem that there's 480 micrograms in 1.6 milliliters. We'll set this equal to the 175 micrograms the doctor ordered and put it over an unknown number of milliliters so we know what to give our patient. We now can solve by using cross multiplication. We can multiply 480 micrograms times x ml equals 1.6 milliliters times 175 micrograms. Again, to get the x by itself, we need to divide both sides by 480 micrograms. .480 micrograms cancels out on the left, leaving us just with x mLs. On the right-hand side, the unit micrograms cancel, and we're left with 1.6 milliliters times 175 divided by 480, and we discover we need to give 0.58 milliliters. Since we need to round this to the tenths place, the 5 is in the tenths place, and the 8 tells us to round up. Therefore, we give 0.6 milliliters. Third way to perform this calculation is by using dimensional analysis. In this case, we'll start with the doctor's order, 175 micrograms. We're going to put micrograms at the bottom and milliliters at the top. That way micrograms will cancel and we'll be left with the milliliters we needed to deliver. We know from the problem that in every 1.6 milliliters, there's 480 micrograms. As you can see, micrograms cancel and we're left with milliliters. If we multiply 175 times 1.6 and then divide by 480, you get 0.58. However, since we need to round to the tenths place, the 5 is in the tenths place, the 8 tells us to round up, therefore we will administer 0.6 milliliters. The fourth way to do this calculation is by the formula method. In that case, we take the doctor's order, 175 micrograms, divide by what's on hand, the 480 micrograms, multiply by the quantity it's being delivered in, 1.6 milliliters. Micrograms cancel, and when we perform the operation, 175 divided by 480 times 1.6, we get 0.58 as a result. However, since we need to round to the tenths place, the 5 is in the tenths place, the 8 tells us to round up, and we will deliver 0.6 milliliters.